last lesson, we learned how to multiply and simplify radicals. Today, we're going to look at dividing radicals because it's another important skill when you're working with radical expressions. If you can divide the numerator by the denominator, then you want to do that first. If not, you must do something called rationalize the denominator. The division property of square roots is helpful for simplifying expressions. It specifically states that for every number greater than or equal to 0, and for a being greater than or equal to 0, and b being greater than 0, the square root of a over b is the same as the square root of a over the square root of b. So example, the square root of 16 25ths is the same thing as saying the square root of 16 divided by the square root of 25, which reduces to 4 over 5. If the denominator of the radicand is a perfect square, it's easier to simplify the numerator and denominator separately. If the numerator can be divided by the denominator, you can also try doing that first. If none of that works, then you'll have to do something called rationalizing the denominator. Let's take a look at number 1. I look at number 1 and my brain immediately says 144 is a perfect square and 9 is a perfect square. So I can rewrite this as the square root of 144 over the square root of 9. And I know the square root of 144 is 12 and the square root of 9 is 3. So I can rewrite this as 4. And I'm done at that point in time. Number 2, the square root of 25p to the third over q to the second. Well, I happen to know that I can separate this as the square root of 25p to the third divided by the square root of q to the second. And I know that the square root of 25 is 5, and I can take one of those p's out, and I'm left with one of them underneath the radical. And on the bottom, I can take out one of the q's. And at that point in time, I'm done here because I can't simplify this anymore. And there's no radical in the denominator. It's really, really important that you understand that if you're going to simplify a division problem with radicals, there can be no radicals in the denominator. Okay? You have to make sure there are no radicals in the denominator, no square roots in the denominator. Number 3, I look at this and go, gee, square root of 18 over the square root of 2. But if I put them together, before we separated them, now I'm going to put them back together. Because now I'm going to have the square root of 18 halves. Okay, 18 divided by 2 is 9, so this gives me the square root of 9, and the square root of 9 is 3, and I'm done. You learn to recognize things pretty soon once you get into these. If I look at 4, I know that 24 is divisible by 8, so I'm going to do that first. 8 times 3 is 24, so this is the square root of 3. There is no denominator, so I'm done. I look at number 5 down here. Number 5 has the square root of 100 over the square root of 49. Okay, so I'm going to separate those, square root of 100 over the square root of 49. Square root of 100 is 10, square root of 49 is 7. I'm not going to leave it as an improper fraction because it doesn't need to be changed with next time. Now we get to number 6. Square root of 1/2 isn't very nice. If I divide to separate those, I get the square root of 1 over the square root of 2. The square root of 1 is 1. But I still have a square root of 2 in the denominator. I cannot have a square root in my denominator. So in order to get rid of that, okay, because the square root of 2 is what we call an irrational number. In order to get rid of that irrational number, I must do something called rationalizing the denominator. To rationalize the denominator, I'm just going to multiply it by some form of the number 1. Remember, when working with fractions, 3 over 3 equals 1. 12 over 12 equals 1. So I can multiply a radical by another radical as long as that radical is equal to 1. And I'm not changing my problem, I'm just changing what it looks like. So if I have 1 over the square root of 2, I need to multiply this number by a form of the number 1 so that I get rid of my radical in the bottom. To do that, I'm thinking I look at the bottom and it's the square root of 2. If I multiply by the square root of 2 over the square root of 2, that's a fancy way of saying the number 1. So it doesn't change my problem. It's just changing how it looks, but it doesn't, remember, 3/4 is the same as 6/8, which is the same as 75 over 100. So they're all different forms of the same exact number. So I now am multiplying this by the square root of 2 over the square root of 2. My numerator now becomes the square root of 2, because 1 times the square root of 2 is the square root of 2. And the square root of 2 times the square root of 2, this becomes the square root of 4, which is just 2, because remember, if I have two of the exact same things, the square cancels out the square root. So the square root of 1/2 becomes the square root of 2 over 2. And I kind of moved into problem 7 here. So be careful with that in your notes. I look at number 7. 14 is not divisible by 3. So it doesn't matter how I look at it, I'm going to have to rationalize the denominator. To rationalize the denominator here, I still need a fancy form of the number 1, but I need to get rid of the square root of 3. Well, I'm going to multiply then by the square root of 3 over the square root of 3, because the square root of 3 over the square root of 3 is another fancy way of saying the number 1. Okay. If I multiply 14 by 3, I get 42. Okay, so I'm going to have the square root of 42 over the square root of 9, but the square root of 9 is 3. Because square root of 3 times the square root of 3 just becomes 3. Square root of 6 times the square root of 6 is just 6. 42 is 6 times 7, 6 is 2 times 3, so nothing breaks down, so this ends up to be square root of 42 over 3. You cannot break down, you can't divide 3 into 42 because 42 is inside of the radical and 3 is outside of the radical. In order to reduce them, they both have to either be inside of the radical or both numbers have to be outside the radical. If one is inside the radical and the other one is outside the radical, you cannot reduce them. We look at number 8, we have 2 square roots of 3 divided by 3 square roots of 7. The 3 is perfectly fine to have in the denominator. I can have 3's in my denominator all I want. I can't have the square root of 7. So I need to get rid of the square root of 7. Since it's multiplied, not added or subtracted, the only thing I need to get rid of is the square root of 7. So I can multiply by the square root of 7 over the square root of 7. I do not have to multiply by 3 square roots of 7 because the 3 is a whole number. We're fine there. Now, if I multiply by the square root of 7 over the square root of 7, I get 2 square roots of 21 over 3 times 7, because the square root of 7 times the square root of 7 is 7, and 7 has to be multiplied by the 3 because it's already on the outside. So this becomes 2 square roots of 21 all over 21. 21 doesn't break down, so it just stays as 2 square roots of 21 all over 21. Take a look at our last 2 problems here. I have the square root of 6 over the square root of 75. I don't know about you, but I don't want to be multiplying by 75s. I look at 75 and I think, can that be reduced first? It's the first thing my brain thinks of. Let's make this problem easier. Just like if you're going to reduce a fraction before you multiply it by another fraction, it's a whole lot easier to do that. So I look at the square root of 75 and I go, okay, that's 5 times 25, or excuse me, 5 times 15. 5 times 15. And 15 is 5 times 3. So I can take out the 5's. So this is now the square root of 6 over 5 square roots of 3. Now it's a little easier to deal with. Okay. So now all I have to get rid of is the square root of 3. So I'm going to multiply this by the square root of 3 over the square root of 3. That's going to give me the square root of 6 times 3 is 18 over 5 times 3. Because the square root of 3 times the square root of 3 is 3, and 3 times 5 is 15. I can't really leave it like this because I know the square root of 18 breaks down. 18 is 2 times 9, and 9 is 3 times 3. So the square root of 18 becomes 3 square roots of 2 all over 15. Now, because I have whole numbers out here, these 2 whole numbers, the 5 and the 3 and the 15, can be reduced because they're both outside the radical. So I need to reduce these. So I'm going to reduce this. 3 goes into itself once, so this is the square root of 2 on the top. 3 goes into 15 5 times, so it ends up being the square root of 2 over 5. Number 10. I can't reduce it anymore, so I'm just going to multiply it by the square root of 6 over the square root of 6. So I'm going to get 2 square roots of 18 over 6 times 4 is 24. But the square root of 18 we already know reduces because we did that the last problem. Square root of 18 is 3 square roots of 2, and that 3 has to get multiplied by the 2. Okay, so I basically have this 18 becomes 3 square roots of 2. This 3 has to get multiplied by that 2, so it becomes 6 square roots of 2 over 24. 6 and 24 can reduce. Okay, so if I take it, 6 goes into itself once, and it goes into 24 4 times. So I end up with the square root of 2 over 4. And I'm done. All of that got me the square root of 2 over 4. Okay. Rationalizing the denominator is a very important skill that you'll use in many, many, many other math classes. And you'll use it a lot in geometry. So you need to learn how to do it properly and efficiently. So that's just how you divide with radicals.